So we're diving into this absolutely incredible cosmic puzzle that was just solved, and it's happening right on the surface of our very own sun.
Okay, to really get this, just picture it for a second. What if the sun is covered in these giant, planet-sized rivers made of plasma, kind of like massive conveyor belts? Now, what if scientists just found a brand new one, hidden near the poles, that's flowing completely backwards? That is the exact mystery we are unpacking today.
All right, first things first. We have to introduce the main character in this whole story. It's this massive, powerful feature of the sun that we've known about for a while, but, well, we've never really fully understood it.
So it's called the meridional flow, and you can just think of it as a colossal, super slow-moving river of plasma. It acts like a giant conveyor belt that's always circulating across the sun's entire surface, flowing from the equator up towards the poles in each hemisphere.
Now, why should you care about this giant conveyor belt? Well, here's the deal. It's not just moving plasma around, it's dragging the sun's magnetic fields along for the ride. And that process is the engine that drives the sun's famous 11-year cycle of activity. You know, the one that gives us solar flares and all the space weather that can impact us right here on Earth. So yeah, understanding this flow is absolutely crucial to understanding the sun itself.
Okay, but this is where the story gets really interesting. For decades, our whole picture of this flow had a massive blind spot, the poles. We just couldn't get a clear look up there.
And look, this wasn't some tiny detail nobody cared about. The scientists behind this new discovery said it themselves just this year. The flow near the solar poles was, and I quote, still unclear. It was a huge, nagging question in solar physics for a long, long time.
So, what changed? Well, the breakthrough came from Japan's Hinode satellite. It gave us this absolutely stunning, high-resolution view of the sun's polar magnetic fields better than anything we'd ever seen before. And hidden in all that incredible data was the one critical clue that would crack this case wide open. And this was the clue, the real head-scratcher. See, everyone just assumed that as this big conveyor belt carried magnetic material to the poles, it would just pile up, right? That would make the magnetic field super strong right at the top. But Hinode saw the exact opposite. The fields were actually getting weaker near the poles. This observation just didn't make any sense with the models we had.
So now the scientists have this major contradiction. Their observations completely defied their theories. The next logical step? They had to figure out why. And to do that, they needed to build a digital twin of the sun.
I mean, think about it. You can't exactly run an experiment on the sun itself, right? So how in the world do you test a new idea about how it works? Well, you build a virtual one. Scientists use this amazing tool called a surface flux transport model, or SFT for short. The easiest way to think about it is like a digital twin of the sun's surface. They program in everything they know, the sun's rotation, the plasma physics, that giant conveyor belt, and then they hit go and let the simulation run to see if it behaves like the real sun. And this is where the problem just stared them right in the face. When they ran the simulation with the standard, old model, it predicted that magnetic fields would pile up at the poles and get stronger. This completely contradicted what the Hinode satellite was actually seeing. The model was wrong. It was broken.
But you know, sometimes a failure like that is exactly what you need for a breakthrough. It forced them to ask, okay, if the old model doesn't work, what could possibly explain those weaker fields at the poles?
So they decided to test a radical idea. They thought, okay, what if there isn't just one big conveyor belt? What if, right up near the pole, a second, smaller current is flowing in the opposite direction, a reverse current, pushing magnetic material away from the pole? They plugged this new counter cell into their digital twin, ran the simulation again, and wow, the result was stunning. The new model was a perfect match for reality. The only way to explain the weaker fields Hinode observed was if this reverse current truly existed.
So just how fast is this newly discovered solar river? Get this, it's moving at about 3 meters per second. That's basically a brisk walking pace. A tiny detail in the grand scheme of the sun, but one that changes everything.
And this wasn't just a guess. The data proved it. You see this goodness of fit value here? It basically tells us how well the simulation matches reality. A value of 1 is perfect. With no reverse flow, the fit is, well, it's not great, only 0.769. But at 3 meters per second, the fit becomes an incredible 0.950. That is, without a doubt, the best match. The numbers confirmed the discovery.
So, with the puzzle finally solved, we now have to literally redraw our map of the sun's surface to include this brand new feature. So here's our new understanding. The sun doesn't have a single-cell system. It has a double-cell one. There's the main conveyor belt we knew about, flowing from the equator up to about 70 degrees latitude. And then there's this newly discovered countercell, a reverse current flowing from the pole back down to that same 70-degree line. And right there, at that meeting point, the two plasma rivers plunge down into the sun's interior.
And this isn't just an academic detail. This completely reshapes our model of the sun's magnetic engine. That engine is what generates solar storms and space weather, which can impact our satellites, power grids, and even our climate here on Earth. A more accurate model means better predictions.
And the story isn't over either. As the researchers point out, missions that are flying right now, like the Solar Orbiter, and future missions will give us an even better view from above the sun's poles, helping us understand this brand new feature in even greater detail. It's an amazing reminder that even with our own star, there are still fundamental discoveries to be made. A tiny current, moving at walking speed, was the missing piece to a puzzle that has stumped scientists for decades. It really makes you wonder, what other profound secrets about our universe are still out there, just hiding in plain sight?